True Projects. In this video, we are going to explain about a project titled Movie Recommendation Using Neural Collaborative Filtering and Deep Learning. In the digital era, the entertainment sector has undergone a transformation owing to the copious data generated from the user interaction, preferences, and behaviors across diverse platforms. Movies, a beloved form of entertainment, confront users with an overwhelming array of choices, making the personalized movie recommendation indispensable for enriching their experience. Conventional recommendation systems often leaned on the collaborative filtering method, suggesting the movies based on the historical preferences and the user similarities. However, these approaches grappled with the issues of scalability and sparse data handling. Recent strides in the deep learning and the neural networks have ushered in most potent recommendation system. Among these innovations, neural collaborative filtering stands out, amalgamating the neural networks and the collaborative filtering to furnish more precise and individualized movie suggestions. MCF proves the lies in capturing the intricate pattern and the non-linear connection within the user-item interaction, culminating in heightened performance and heightened user contentment. This evolution in recommendation technique process to further elevate the realm of personalized movie recommendation. The aim of this project is to apply and investigate the efficacy of the neural collaborative filtering and the advanced deep learning method in the realm of movie recommendation. The specific objective encompasses the grasping the fundamental principle of collaborative filtering and the deep learning techniques, constructing and training a neural collaborative filtering model using cutting-edge deep learning methodology, gauging the NCF model's performance on the movie dataset to quantify its precision and efficiency to the outcome with conventional collaborative filtering approach and alternative recommendation system. Delving into the ramification of varied hyperparameter architectures and optimization strategies on the NCF model's performance, showcasing the potential advantage offered by neural collaborative filtering over the established methods like matrix factorization, content-based suggestion, and furnishing the insight into both the strength and the limitation of the neural collaborative filtering within the sphere of movie recommendation. These are the basic requirements that are needed to build this project. The software requirements are Python EDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. This project commences by importing the necessary packages and libraries, establishing the groundwork for the implementation of movie recommendation system through the neural collaborative filtering and the deep learning technique. And the next one is loading the dataset. The dataset containing the movie-related information is loaded, serving as the foundation for the movie recommendation system, training and the evaluation. And the next step is processing the content. Initial data processing steps are undertaken to ensure the data quality and the consistency. And the next step is feature extraction and splitting the dataset. Relevant features are extracted from the dataset to form the basis for the model training and the evaluation. And the dataset is then divided into the training and testing subset. And the next one is filtering out the content. The content is filtered to remove the irrelevant information, ensuring the focus remains on essential attributes for the recommendation. And the next one is embedding the words. Words in the test are embedded into the numerical representation, enabling the utilization of the textual data for the recommendation purpose. And the next one is building the model. Here various models are built, and the first one is user similarity using cosine similarity. This method computes the similarity between the users based on their movie preference. By calculating the cosine similarity of the user vectors representing their liked movie, the system identifies the user with a similar taste and recommends the movies favored by those with comparable preference. And the next one is item-based collaborative filtering. Item-based collaborative filtering suggests the movies by determining the similarity to the other movies previously liked by the user. The system identifies the movies that are more similar to the ones the user has enjoyed, ensuring the recommendation align with the preference. And the next one is matrix factorization. It involves decomposing the user item interaction matrix into the latent factor. This factor captures the hidden pattern and the preference in the data, enabling the accurate movie recommendation by understanding the underlying relationship between the user and the item. And the next one is neural network. The basic neural network is employed to learn the complex pattern from the movie preferences. It involves the multiple layers of the interconnected neurons, with each layer learning different levels of abstraction. The network levels learn feature to predict movie preference and offer the recommendation. And the next one is neural collaborative filtering. Combine the neural network and collaborative filtering. It captures the intricate user item interaction using the neural network architecture, enhancing the accuracy and the personalization of recommendation by effectively modeling on the non-linear relationship. And the next one is KNN, stands for K nearest neighbor, recommends the movie based on the preference of user similar to the target user. It identifies the K nearest user with the compatible movie choice and suggests the movies that these neighbors have liked but the target hasn't yet seen. And the next one is LSTM. Long short-term memory is a recurrent neural network architecture suitable for the sequence-like movie preference over time. It captures the temporal dependence in the user interaction, allowing the model to grasp the evolving preference and make the sequential movie recommendation. And the last one is BiLSTM. It stands for Bidirectional LSTM, enhance the LSTM capability by processing the sequence in both the forward and the backward direction. This aids in capturing the context from both the past and the future preference, enabling a more comprehensive understanding of user preference and resulting in the improved movie recommendation. And the next step is the user provides the input. Here we need to build an web framework name of with of Flask. Here we need to provide the input where we give the preference of the movie and the year of it, like cause of action, drama, or of comedy. And the next one is the input is processed and function call is used for recommending the movies. The input undergoes the processing to align it with the model's requirement. And the next one is of final outcome is displayed. The project concludes by presenting the recommendation outcome to the user based on the input with the help of the web interface as Flask. And the execution of the project, to execute the project first we need to open the code folder. And this is the code folder containing of various files within the data folder containing of the CSV files that will be used in this project, and the static folder containing of the CSS, JavaScript, font, images files within it, and the template folder containing of the HTML documents like of home, index, results, sign in, sign up pages within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and basis code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, we'll execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm opening it and pasting this link and then click on the enter button. Here it redirected to this page containing of some information and the title of the project. And then click on the sign up button. Here it will redirect to the sign in page and the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm clicking on the sign in button. Redirect to the sign in page containing of the username and password, and we need to fill those details and then click on the sign in button. Here it redirected to this page containing of the genre and year, about and sign out pages. Click on the genre and year, and we need to enter the genre as of action or anything as of our choice, and I'm entering that as of action and year as of 2009, and then click on enter button. Here it predicted the movies based on the action and of the year of 2009 and to up to that mark within it. And then click on the genre and year, and we can view the another input as of comedy and year as of 2005, and then click on the enter button. Comedy, and then click on the enter button. Here it predicted that as of like this with the comedy genre with an year of 2005 and above. In this way, we can recommend the movies for the users by this manner with the help of this deep learning and the collaborative filtering techniques. And in conclusion, the study explored the application of neural collaborative filtering and the deep learning technique with a personalized movie recommendation. The result demonstrated the effectiveness of NCF in capturing the intricate user-item interaction, leading to more accurate and the personalized movie suggestion. By leveraging the neural network, the model effectively learned the complex pattern from the user preference, making it a superior alternative to the additional collaborative filtering method. Through our experiment, we observed the NSCF model outperformed the conventional recommendation system, showcasing its potential to enhance the user experience and increase the user engagement on the movie platforms. Additionally, we investigated the impact of various hyperparameters and the architectures on the NCF model performance, offering the valuable insight for the future research and the optimization.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.